All right, good morning. So today we are going to talk about mixing problems, and I know these are kind of a complicated problem for us. So I'm just going to guide us through one, and then later I'll put up a worksheet for another one, and then I'm just going to put up a work through with that one as well. So we have a tank initially contains 10 pounds of salt in 60 gallons of water. Water with a half a pound of salt per gallon is added to the tank at 6 gallons per minute, and the resulting solution leaves at the same rate. Now, you guys are going to see, you are going to encounter some problems where this is not going to be the case. I'm going to say that I don't think that's a calculus 2 type of problem. That's a differential equations problem. I would not ask you when the volumes are changing. Okay, we can look at a few if you really want, but that's not, I think that's beyond the scope of a Calc 2 class. Okay, so let's set up a model, and mathematicians like models that are fairly easy. So we're going to go with the change of Q equals the amount of salt in. Okay, so we're going to go with amount in minus amount out. Okay, Q is equal to the pounds of salt in the tank. Okay, so dQ is the change in the amount of salt. Okay, when I learned this, we typically used Q for quantity. You can use whatever letter you'd like. If you want to use S for salt, that's fine. If you want to use N for NaCl, that's fine. Whatever letter you feel comfortable with. So setting this up, we're going to have dQ and by dt, okay? And the amount of salt in, we're going to make another model for the amount in, okay? This is going to be the concentration in, oops, the concentration in times the rate in minus the concentration out times the rate out, okay? So let's go ahead and let's fill in some numbers here. So we still have a dq dt. This is equal to, well, how much is coming in? It's adding at 6 gallons per minute. So my conc in is going to be 6. I'm sorry, conc in is half a pound. Sorry, we have half a pound per salt per gallon. The rate in, that's my 6 gallons per minute. Okay, notice the gallons cancel off here. So what as I have is half a pound per minute. So this is, I'm just going to leave this times 6. So we have 3 pounds per minute. Okay, minus, and we have conc out here. And the I'm going to save conc out for a minute. It's leaving at the same rate. So this is still 6 gallons per minute. Okay, now conc out. The concentration is the amount of salt in there divided by its volume. Okay, I don't know how much salt's in the tank. I mean, I know it starts, right, with 10 pounds of salt in the tank, but as soon as you start adding, as soon as you start adding this, I don't know how much is going to be in there later. So instead of putting a static number in here, I'm just going to say, how about we just put the amount of salt in the tank, which is Q, divided by the volume, okay, which was 60 gallons. Okay, now this can change, doesn't have to be a static volume, and that's where you're going to introduce another variable. Your T is going to be in here, and that's what makes this a little bit more complicated. So this is going to be 6 over 60, that's going to be 1/10 Q. Okay, so just to summarize this, okay, and please excuse my crummy handwriting, we're going to have our dQ by dt. This is equal to 3 pounds per minute in minus 1/10 Q out. Okay, we're going to go ahead and take our limit. So we're going to have dQ by dt is equal to 3 minus 1/10 Q. let's put this in standard form, okay, because this looks like a differential equation. If you wanted to do this Euler's method, this would be the proper form, but this is linear, so we can go ahead and do that. So this is dq by dt plus 1 over 10q equals 3. This looks like a first order linear differential equation that we can use an integrating factor on now. All right, so let's go ahead. I'm going to rewrite dq by dt as just q tick, okay, plus 1 over 10q is equal to 3. Now my integrating factor, right, remember that's a row. Here, that's row. That's my row anyway, is equal to e to the integral of whatever's before the q. And if there's t's in here, then so be it. But since there isn't, this is 1 over 10 dt, okay, and that is equal to e to the 1 over 10 t. All right. Now remember, we got to multiply the integrating factor by every term in our equation. Okay, so we're going to have q tick times e to the 1 over 10 t plus 1 over 10 e to the 1 over 10 t times q, and that is equal to 3e to the 1 over 10 t. Okay. Now, the way the integrating factors are supposed to work is I know that the left-hand side is now the derivative of q times e to the 1 over 10 t. Okay, it's the derivative of e times 1 t e to the 1 over 10 t. I urge you, take the product rule and differentiate this implicitly. Take the product rule of this and see if you get the same thing. You always should. Okay, and that is equal to 3e to the 1 over 10 t. Now the left-hand side, when we integrate, that's going to be really easy. This might be a little tricky, especially if you're a little bit out of practice. And if you're a little bit out of practice, what I recommend you to do is to make a little side problem over here. What if we just have to integrate, okay, 3e to the 1 over 10 t. Remember, it's like a Calc 1 problem, but like I said, if you're a little bit out of practice, maybe this is harder than it should be. So we're going to move the constant out. Okay, so 3e to the 1 over 10 t dt. Now we're going to say let u equal whatever's in the exponent position. So this is 1 over 10 t du. And every time you make a substitution in calculus, you should always take its derivative. That's simply 1 over 10 dt. Okay, and this is 10 du is equal to dt. So if we want to just, I'm just doing this mini problem over here. Okay, we're going to insert the answer back over here because we're just going to integrate both sides. But this is going to be 3 times the integral, and then we have e to the 1 over 10 t. We said that u was equal to 1 over 10 t, and my dt here, okay, my dt is equal to 10 du. And we can go ahead and say that's 30. Okay, that's a 30. Integral e to the u du. Okay, that's about the easiest integral we could ever ask. So that's just e to the u plus c. Okay, so we have 30, and the reason why we don't distribute the 30 is that we have a constant here, and 30 times a constant is still a constant. So if you multiply it, great, and if you don't, that's probably easier because who wants to track a whole bunch of constants? Okay, so this is 30 e to the, what the heck was u again? U was 1 over 10 t plus c, and that's what we're going to put in here. Okay, so when we integrate both sides, okay, we go back and we integrate both sides here. Okay, this is going to be q e to the 1 over 10 t. This is equal, well, what's the result of this integral? We did all of this work to figure that out. We're just going to plug this in. We're not going to do it again. Okay, and this was equal to 30 e to the 1 over 10 t plus c. Well, we got to isolate q now. Okay, so what we're going to do is we're going to multiply both sides, okay, by e to the negative 1 over 10 t. That's going to clean off the left-hand side. when I multiply this e to the negative 1 over 10t here, we're going to end up with an e to the 0. E to the 0 is 1. So we're going to end up with a 30, because this cancels that out, plus c e to the negative 1 over 10t. These are the kinds of problems where it's really, really important never to forget your constant of integration, because that's how you're getting the rest of the problem. That's how you're getting the function part in your problem. Okay, so be really careful about that. Okay, now we can go tackle what the first sentence was in our problem. Okay, so I'm going to go all the way back up here. So a tank initially contains 10 pounds of salt in 60 gallons of water. That's our initial condition. I know it's the last thing you need in the problem, and it's the first thing they offer you. So you have to remember that it's kind of a tricky thing here. All right. So let's go ahead and take a look at that. So I'm just going to start down here. So it said that, right, it said when t was equal to 0, okay, when t was equal to 0, then we had started off with, and excuse me, I got to look, 10 pounds. Okay, q is equal to 10. Okay, so we're just going to plug that in. We're going to say 10 equals, that's my q, right? So q equals 30 plus ce to the negative 1 over 10 times 0. 1 over 10 times 0 is 0, and e to the 0 is equal to 1. Okay, hopefully you don't need a calculator for that. All right, so we have 10 is equal to 30 plus c, and I think you can go ahead and generate that c is equal to negative 20. All right, so our final function here, okay, to find the amount of salt at any time is q is equal to 30 minus 20 e to the negative 1 over 10 t. Okay, and that is the function value that we have there. All right. Let's see if I can do this real quick. All right. We're going to go ahead and see if I can't share something else here. So we're going to go ahead and share this guy here. So I've gone ahead and written out this thing in Desmos. I'm sorry, let me go ahead and do this one. We'll scroll in a bit. Okay, so this is just Desmos. This is a fantastic website for graphing. I recommend it for everything you ever need to do. It even shows up on my phone. It's great. Okay, and then we can see the salt is rising up until it gets to this 30 mark, and it kind of makes sense that we have half a pound of salt going into a 60-pound tank, that eventually the concentration is going to be 30 pounds of salt for the 60 gallons of water. Okay, so that's how you do that kind of a problem. Please practice these. I know they're hard, okay, but I think we can go ahead and do that. So I'm going to stop.